Hello. DBSCAN, the density-based clustering algorithm. Now we're in a position to discuss this. Having gone through the concepts, quickly we take a recap. Neighborhood, for which we have epsilon. For dense neighborhood, we have this number of points which should be present in the cluster to form it as a dense neighborhood. Then we have the definition of core objects. Then the epsilon neighborhood, what that means. Then the concepts density reachable, density connected. We have discussed these previously, and I shall provide a link to these videos in my description box. So here comes the DBSCAN algorithm. What does it broadly say? That we start with all points which are not yet visited, unvisited. We select a point, mark it as visited or processed. If it is a core point, we form a cluster, including this as member. Then we pick up its neighborhood. For the points in the neighborhood, we go on marking them as visited, and if they are core, we include their neighborhoods into our N. And if P dash is not a member of a cluster, we add it to this cluster C. And having finished with this N, this iteration of the step 4, we output the cluster and we go back because all points have not been marked as visited, and we select a point and go forward. In the case P is not a core point, we mark it as noise. Okay, so let us start to go through the algorithm step by step with an example. So we have an example. We have our points A, B, C, D, E, F, G, H. See, all these points are marked as unvisited, and we have epsilon equal to 2 and min points 3. This is our usual parameter setting for all our examples. So all points have been added to the set unvisited, and visited set is empty. We come to the second step. Select a point, mark it as visited. So here, select a point E and update the sets. See, the point E has moved to the set visited and it has been removed from this set. We come to the third step. If P is core, form a cluster, include it as a member. We see that the chosen object was E. This is E. And what about its epsilon neighborhood? Because epsilon equal to 2. So we have B, we have A, we have H, we have G, and E itself. So there we write the epsilon neighborhood. Number of points are more than min points. We needed only 3. We have 5. So E is a core object. Create a cluster, and E is a member. Right? So this was what happened with the first point which we had chosen. We again come and go to the next step where we are going to take the neighborhood of that point and put it in a set. So this set is nothing but the epsilon neighborhood which we saw earlier, and C1 is the cluster. Come back. Now, see here, this step 4 will need the processing of all the members in N, and as you can see in this bullet here, if P dash is a core point, N equal to N union epsilon neighborhood of P dash. So N will go on expanding also. So this step 4 will take several iterations, as we'll see. So we are writing the steps here, so for convenience of understanding. So what is our state now? N is A, B, E, H, G, and C1 is E. So choose the first. See, this is the first P dash element of N. All of it we are marking. So P dash is A, and it was unvisited. So now it has been included into visited. A is a core point, as we can see. B, E, and H also are in its neighborhood. So what do we do when P dash is a core point? We include its neighborhood into N. However, the epsilon neighborhood of A includes all those points which are already in N. So no point is added to N, and P dash is not a member of any cluster, so add to C. So this is our state. Our N has now come down to BHG because A and E are processed, BHG, and C1 now has been expanded to include A along with E. Now we go to the second iteration. This is where we had left in the previous slide. N equal to BHG, C1 is this. So we again pick up a point, which is B, the first one here. Update unvisited and visited. B comes down here into visited, and unvisited becomes one lesser. Now B is a core point, and C. There is an addition to N. Why? Because B, the epsilon neighborhood of B also includes C. The epsilon neighborhood of B, because this distance is 2. So C also gets included in this neighborhood, and C previously is not present in N. Okay, so N gets updated. We remove B because it has been processed. So HG were already there here. So we now have HGC. Like we had expected, N will be enhanced during these iterations. So N is equal to HGC, and C1 now becomes EAB. Right? We move forward. So N is HGC, C1 is EAB. So we pick up now H, update these two sets, and H is a core point. See, H is a core point because its neighborhood contains E, it contains A, it contains G, it contains F. Okay, so new point F, F was not there here. See, H, G and C are there. G is already there because initially we had chosen E. So G was close to E in its neighborhood. So H, the neighborhood of H includes F as well. So F is added to N, and H is added to the cluster. So here our current state of N is now G, C, and F, and C1 gets expanded. We had E first, A, then B later on, and H is the latest addition. Right? So GCF is our neighborhood, which is still to be explored. Here, we see it here, GCF. So we now pick up G, okay, update the sets unvisited and visited. G is a core point because see, F is in its neighborhood, H is in its neighborhood, E also, but we don't have any new points to be added to N. F, H, C already are there or have been processed. So G is the only action you do is G is added to the cluster. See, E, A, B, H, and now comes G, and our N gets reduced by 1 because no new additions and G has been processed. See, slowly we can see the cluster building. So N was CF when we left the last slide. We pick up C. We change these two sets comprising of unvisited and visited. C is not a core point. Now see, this is a special kind of point. It is not a core point. So we don't have any considerations of whether new points will be added to N. But right now it is not a member of any cluster. It will get added to the cluster. And we can see here this border object. So border objects are those which are themselves not core but fall in the neighborhood of a core point. Okay, border objects fall in the neighborhood of a core point. So our N becomes only one element F, and our set is now EABHGC. EABHGC. Being a border point, it gets included itself, but it cannot bring in more points. So lastly, only F remains to be processed. We update only D is here in the unvisited set. The whole visited comprises of the rest of the elements. F is again a core point, but no new points added because G, H already we are done through. So F does not bring in more points. It is added to the cluster. So here EABHGC. This is our present cluster. We come back here now. See, we have finished the processing of the set of points in F. So right now we have the cluster C1. C1 is ready. So what else remains in the unvisited? We had only one point D remaining. See, now the unvisited becomes empty set, and visited comprises of all the points. D is not a core point, and we started with D. It is not a core point. It was not considered previously because it did not fall in the neighborhood of any core point. So it is not even a border object. So mark it as noise. So what is our outcome here? A cluster C1 and the noise D. This is our cluster C1 and noise D. This is the output of our iteration on the data set. So here in this last slide, we would see the formation of the cluster. See, we have included the data points in the order in which they were added to the cluster. So we start with E, next comes A, then B, then we have H. See how the density based algorithm is pulling in data points. Then we have G. So it's like this branch coming out and pulling in G. Then we have C. It gets pulled in here. Finally, we have F. So this is the building of the cluster, or how the dense regions grow by the concept of density connectedness. Okay, density reachable, density connected. These concepts are all used here. So we output the cluster C1 and the output noise D. So with this we come to the end of this discussion on DBSCAN algorithm, and with this walkthrough of an example, I hope the concept is clear to you. We shall discuss this again in different examples. Thank you. Thanks for watching.